Alkenes are a type of hydrocarbon, so compounds made only of carbon and hydrogen that have at least one double bond. And the naming convention for alkenes is similar to that for alkanes. So the number of carbons is represented by this prefix, but rather than end in ane, alkenes end in ene. And unlike alkanes, where the simplest alkane is methane with one carbon, the simplest alkene has two carbons because it's defined by that double bond between two carbons. So ethene is the simplest alkene. And we remember that double bonds are stronger than single bonds because greater energy is required to break the double bond, and so they're shorter. Double bonds are shorter than single bonds. So let's take a look at the geometry of ethene. If we look at its Lewis dot structure, and its two-dimensional structure, we clearly see there are 4 electrons being shared between the carbon. Carbon still fulfills the octet rule, but we look at what is around each carbon, only 3 bonds. Now there are 4 electrons in this double bond, but they are localized between the 2 carbon atoms. So even though there are more electrons in this bond than in the single bond between carbon and hydrogen, they still repel to about the same extent as a single bond because they're all in the same area. So how do these 3 bonding pairs get as far apart as possible? In what's known as a trigonal planar arrangement. So the bond angle between each of these bonds is 120, and it's actually a planar molecule. So for ethene, there is no 3-dimensional structure for it because it's a 2-dimensional molecule.